Okay, let's take a look at our fourth example dealing with the vertex expressions of a quadratic equation. So here the question is, which of the following is an equivalent form of the function f, above, in which the minimum value of f appears as a constant coefficient? So the fact that they talk about the word minimum tells you that they're looking at the vertex form. Remember, when I draw this quadratic equation here, uh, as you can see, my x is going to cross the line x equal to 4 somewhere here. So let's actually do this. So it's going to have x equal to, as you can see, when I set this to be equal to 0, then I get x is equal to 4 or x equal to minus 6. So I'm going to have this as minus 6, and I have this here as positive 4 right here. All right. So if I have this as negative 6, then my vectors, which we just x vectors, will be equal to minus 6 plus 4 divided by 2, which will be equal to minus 2, 2, and that's equal to minus 1. So that is going to give my vector space. So if I'm writing my equation, but remember we said when I write my vector is equal to a outside x minus k squared plus h. If this is k, that means it's positive. So since this is negative, then it's going to be equal to something like x plus 1 squared plus h. So when you see the plus here, that means your vertex x is positive. Sorry, it's negative. Yeah, because it becomes negative and negative. So that means your vertex has to be in this form, and a can be 1 all the time. So x plus 1. So if you go to your system, if you want to write this now, the fact that this is minimum means they want you to write the vertex form. This is not correct. This is not correct. So this is also not correct because I have this here, and therefore this is the only one. Now, if you want to cross check this also, now once you get your x vectors is equal to negative 1, you can plug it into your y equation, and that gives you my y vectors will be equal to minus 1 plus 6, and then minus 1 minus 4, which is equal to 5 times minus 5, which gives me minus 25. So your equation will be in the form y is equal to ax plus 1 squared minus 25. And that is what you see right here, right? Where a is equal to 1 in this particular case. So your answer is still D. Now, let's take this time and actually play with the vectors form. So if you want to do the vectors form, let's go ahead and actually expand this, distribute this. So we are going to distribute this, and this will become x squared minus 4x plus 6x minus 24, right? And that is equal to x squared plus 2x minus 24. Now, if you want to do this in vectors form, then this becomes, we're going to take this x squared, we're going to keep our 2x, and then we're going to add plus half of this, which have been plus 1 all squared. We're going to keep our 24, and we're going to subtract plus 1 also squared. This is, how you do, we call it completing the square. So if you want to do that, then this becomes, this whole one here become x plus 1 squared. And I have my minus 24 minus 1 squared is 1. So this becomes x plus 1 squared minus 25. See, and that is equal to this. Is that beautiful? Yeah. And so that is how you solve this very simple equation to provide a vertex form, which shows that the minimum point occurs at x is equal to, technically x equal to negative 1, and y will be at negative 25, right? So it's going to be this point here. If I draw this, then it's going to be something like this right here. So my vertex, this is negative 1, and this will be negative 25, something like that. All right.